with section 1.2, what I'm going to give you now, instead of looking again at just telling me what you think, now you're going to be able to realize it or figure out what's happening just based on where the numbers are at. Okay? So we're still going to talk about transformations. We're still going to talk about the translation, the reflection, and the stretch or shrink, except for this time, I'm going to be giving you the problem, and then you're going to be able to figure it out just based on where it's located. So the first one that we're going to talk about is the translation. What's a translation again, you guys? What does it mean to translate something? To shift, right. And if you didn't notice on some of the other things that we've been doing, when we're shifting, we're either shifting one of four directions. We're either going to go up or down, or we're going to go left or right. Okay? So the first type of translation that we have is a vertical translation. And a vertical translation happens when you add or subtract outside of grouping symbols. I'm going to abbreviate the words grouping symbols as GS, just so you guys are aware of it. So when I add or subtract on the outside, that's going to shift it up if it's positive, down if it's negative. Okay? So if you think back to the problems that you've had the last couple days, when you had a +7 on the outside, what did it do? It went up 7. Or if you had a -1/3 on the outside, what did it do? It went down 1/3. Where was it located at in relation to the problem? Was it outside of the grouping symbol or inside of the grouping symbol? Every single one of those was on the outside, so therefore, that would have been up or down. Okay? Just to kind of give you an example of one of those, if you had something like this, x plus 5, would that be up or down? Up. How far? By 5. What if you had something like this? Well, that would be down by 3 because it is on the outside of the grouping symbol. Now I want to get back to the first one that I put up there for f of x. Do you notice that there isn't a grouping symbol? There is not a single grouping symbol on that first f, is there? There's not. Okay, so don't assume that there is one. Unless you see one, there isn't one. So for instance, on the f of x, that x plus 5, the plus 5 is outside, not inside. There's no parentheses around anything there. So be careful not to get that confused. Okay? Those are examples of up and down. So again, what's going to happen is if it says vertical translation, up 4, then it should be a +4 on the outside. Okay? The other type that you also have is you have the horizontal translations. And if vertical happened when you added it on the outside, what do you think horizontal does? Yeah. Happens when adding or subtracting inside the grouping symbol. Now, here's where it gets goofy. It's adding goes left, and subtracting goes to the right. It is backwards from what you would think. If it said x minus 2 inside the grouping symbol, that actually goes to the right 2. When you see a minus in front of it, I know you guys always assume that we're going left or down. But when it's inside the grouping symbol, that it goes the opposite direction of what the sign is saying. So for instance, if I give you f of x equals x minus 2, which direction is this going to be shifted? It's going to the right 2. Okay? Or if I had something like this, it's inside the grouping symbol, which way would that go? To the left 1. So I don't know if you guys saw that, but even on the board that I have up here, one of the problems from the worksheet we did, see where it said x plus 2? And that one went left 2. Okay? So when you think about it, it goes the opposite direction from the sign that's inside there. Yes, Emma? Why does it do that? It's kind of like if you imagine setting that equal to 0, like the inside stuff, and solving. So if I were to set this equal to 0, so x minus 2 equals 0, and if I solve it, it would be really x equals 2. So that's why I moved to the right 2. Same thing on the bottom. If I were to set that equal to 0, I get x equals negative 1, which means go left 1. Okay. So anytime you see adding or subtracting now, you'll know, is it going to be shifted left, right, up, or down? So without having to graph them and see what you think, you can look at the equation and know based on that particular info. Okay? So as far as some of the problems that are going to happen for you guys, here's what they're going to look like for that particular part. It's going to say something like this. Here's your function. And it's going to say, write a function whose graph is a translation 3 units down. So where would I put down? Is that inside the grouping symbol or outside the grouping symbol? Outside. Outside. Now when they're referring to the symbol itself or the whole problem, here's what they're referring to. When you write this one, if you're going on the outside of it, you want to go like this. 2x plus 1 is the entire thing, and then you're putting the minus 3 on the outside. Okay? So when you're dealing with vertical today, you guys, when you put it on the outside, you're putting it on the outside of the whole thing. Now, simplify it if you can. Meaning, combine like terms. And if you ever notice how I do this, you'll see me do this many times, but I always underline my like terms. Mainly for me not forgetting one or getting a sign screwed up. So there was no other x's, so 2x stays the same. Then what's 1 minus 3? Negative 2. So that's my answer. Okay. One of the things that you'll notice about this entire assignment today, there's no graphing. You don't have to graph today. It's all about writing them. It's not about graphing them. Okay? In the directions, it might say use your graphing calculator to verify you did it right. And all that is just plug them both in and see if it actually moved down 3 from that first one. Okay? Let me give you another one like that. This one's going to say a translation, same equation. So f of x equals 2x plus 1. And this one's going to say a translation 2 units left. Okay, this time I'm going left. Now, anytime I'm going up or down or I'm doing any type of verticalness, I'm putting parentheses around the entire problem and then putting it on the outside. But when I'm going left or right or I'm doing anything remotely with horizontal directioning, I'm going to put it in for wherever the x's are, inside the grouping symbol. So here's what this one's going to do for us. The 2 is going to stay here like this, and then I'm going to put parentheses. Now what was left 2? Was it a plus or a minus? I'm going to put x plus 2 here, and then put the plus 1. So anytime I'm moving left or right on this assignment, this is where you're going to put it. You're going to take the x and basically put parentheses around it and put that plus or minus in there inside there. If it's vertical, meaning up or down, you're going to put the entire equation around parentheses and then add it on the outside. Now from here, let's simplify. This is going to be distributive property. What's 2 times x?
2x.
And what's 2 times 2? 4. And then I got a plus 1 on the outside. So 2x plus 5. So you just wrote the new equation. Okay? So the first third of your assignment today, this is what you're going to be doing. It's going to be adding and subtracting, whether it's on the inside or outside, that's to be determined. But that's what they're going to be. Again, if you'd like, you could put the original 2x plus 1 in parentheses, and then, or in y1, and in y2 you could put 2x plus 5, and you'll see that it got shifted left 2. All right? That's the first part. Everybody okay with shifting? All right. Then comes the next type that we had, and that's reflection. What was it? What did it mean to be reflected? Do you guys remember? What key word did we use for that, or buzzword did we use for that? Huh? Flip. All right. We use flip. Do you remember me talking a couple days ago? This was Friday, so I know it was a long time ago. But do you remember me talking about how there was 2 different types of flippings? One over the x-axis and the one over the y-axis. Right. Now, it's the same thing here. To flip it over the x-axis, okay, what we do is you'll have a negative sign goes on the outside. Of the grouping symbols. So if we're introducing a negative sign, if we have it going on the outside of the grouping symbol for the x-axis, what do you think the y-axis is going to be? On the inside, right? A negative sign okay. So anytime you see that negative sign, okay, and what I mean by negative sign is if, even if you look at the one that we had from your worksheet, see where there was a negative sign? And we said that it flipped, we reflected because it went down, right? It actually flipped over the x-axis. So if you look at this one, that's on the outside of the grouping symbol. That meant it flipped over the x-axis. So that's how you know for sure that that's what's going on. Now, same type of problems that you had on the translation is going to show up on this one too. It's going to say let f of x be this. And then it's going to say write the function g whose graph is reflected in the x-axis. Okay? Now, when we're talking about x-axis, where did I tell you to put the negative sign? On the outside. Anytime you're doing outside, put the entire problem in parentheses and put a negative on the outside. Or the plus or minus number on the outside. So far, so good. So, negative on the outside is showing the reflection. Now, to simplify this, here's what it doesn't do. It does not go into the absolute value itself, but it does go in the front of it. So you will have negative and then the absolute value of x plus 3. Okay? So you'll have the negative there. Then also, 2 negatives in the back make that a 2 negatives make it a positive. Okay? So for that particular piece, We distributed the negative through to everything that goes on the inside. Okay, everybody okay with that so far? Then, if I took the same thing, what did I have? Plus 3, minus 1? And we reflected it this time over the y-axis, just like the one where I shifted it to the left or to the right. I put just the x in parentheses, didn't I? So now what's going to happen is okay, so notice all I did there, you guys, was I kind of color coordinated it. Does that make sense? Where I just put it in where that's where it's only going into when it's over the y-axis. So when I simplify that out, this is just a negative x here. So now that becomes negative x plus 3 minus 1. The plus 3 and the minus 1 didn't change, but the x did for sure. Okay? What do you think about the reflection piece? And the last piece that we have then is stretch and shrink. And again, like I told you yesterday, I kind of went a little bit too far the first day and talked about horizontal. The only thing we're going to refer to today is vertical. Okay? Vertical stretching or shrinking happens when you multiply outside the grouping symbols. Okay? Now what I mean by outside the grouping symbols, I hope you guys realize this. Maybe you have, maybe you haven't. But one of the things I want to make connections for you about, because this is going to show up later on too. When I added and subtracted on the outside, which way did it shift? When I add or subtract on the outside, which way did it move it? Up or down, which is on the vertical axis. When I reflected it over the x-axis, it went from opening up to opening down, right? I flipped it over the vertical axis. When I'm multiplying on the out, and notice where the negative sign was for that too. It's on the outside. Where's the stuff happening for vertical? Outside. Anytime you're vertical, it should be something going on the outside. And anytime you're horizontal, it should be happening on the inside. Right. So here's what's going to happen for stretching and shrinking and how you're going to know. If the number, and I'm going to use the letter A to represent a number. If the number is bigger than 1, it's going to stretch by A, or whatever that number happened to be. If the number is between 0 and 1, it's going to shrink by whatever A happens to be. So now, I kind of put that in a little bit of technical terms, but I want to make sure you guys know what that means. Just having an A there, you guys, is nothing more than me just telling you a number. What's a number bigger than 1? 2? Anything else? Anything above 1. Like, what about the number 5/3? Is 5/3 bigger than 1? Yeah. Or like the one Nicole asked me to help with on the worksheet. It was 3/2 in the front of it, right? Was 3/2 bigger than 1? Yeah, and if you look back at what you guys turned in on the worksheet, didn't you tell me it stretched? And look where the 2/3 was. It was on the outside. Now, anybody know what it means by 0 is less than A, which is less than 1? kind of the tricky one. Does anybody know what that means? What's a number between 0 and 1? Half. More specifically, what Jacob said was, right, Jacob? You said that? It's a fraction. But 5/3, for instance, an improper fraction, is a stretch. But if you have a shrink, like if I had on your assignment that you guys turned in, do you remember the one that had 1/10 in the front of it? That would have been a shrink. And remember that one was a U? And it got really wide when you put it in your graphing calculator, didn't it? Because it got shrunk. This is going to be the same philosophy that we did for the other two types of transformations. Again, what's going to happen is they're going to give you something like this, where it's going to say let f of x equal the absolute value of x minus 3 minus 5. And it's going to say a vertical stretch by 2. Okay, a vertical stretch by 2. So if I'm going to take that problem and I'm going to vertically stretch it by 2, remember when we had the vertical for adding and subtracting? We put the entire thing in parentheses, right? So do the same thing. And then we have a 2 on the outside. And then as far as the simplify part goes, 2 times this is 2 times this. We do not distribute into absolute value symbols. And then what's 2 times negative 5? Negative 10. Would I do the same process if it was a fraction? Like if I were to take the exact same thing and say I want you to vertically shrink it by 1/5, would you do the same thing? Would you put it in parentheses and multiply it in there? Again, like I told you, we're not doing horizontal right now. It's just vertical. So they're all the same like that. This is what you're doing today. It's just like that. It's going to be either, and it'll say a vertical translation or a horizontal translation. It's not going to give you 2 at the same time. It'll be a reflection over the x or a reflection over the y. It's not going to give you both at the same time. And then it'll be a vertical stretch or a vertical shrink. It's not going to give you both at the same time. It's only going to give you one piece. What do you think? Not too terrible? All right, so on page 16 to 17, we're going 3 to 24, multiples of 3.